Okay, here's another example of rational inequalities. So we have 10 over x plus 8 is greater than or equal to 2. So we know we're going to be able to solve the equation by multiplying both sides by the LCD. So we'll do the same thing with the inequality. So my LCD is going to be x plus 8. But remember, I have two different possibilities because x plus 8 could be positive, in which case I don't change the direction of the inequality. It could be negative, I do. So I've got two different cases. So I'll break this up into case 1, case 2. Case 1, x plus 8 is positive, greater than or equal to 0. And case 2, x plus 8 is negative or less than 0. All right, so we'll start over here. Case 1, 10 over x plus 8 is greater than or equal to 2. I'll multiply both sides by the LCD. X plus 8. And in this case, since x plus 8 is positive, I don't have to change the direction of the inequality. So the x plus 8's here make 1. So now I've got 10 is greater than or equal to 2x plus 16. And then if I subtract 16 from both sides, and I can subtract both sides, I can, and it will change the direction of the inequality. It's just when you multiply or divide by a negative number. So I have negative 6 is greater than or equal to 2x. Then I can divide both sides by a positive, so I got a 2. That's okay. So that gives me that negative 3 is greater than or equal to x, which actually implies that x is less than or equal to negative 3. So that's, we usually write the x on the left. So x is less than or x is greater than. So negative 3 greater than x implies that x is less than or equal to negative 3. All right, and we also have, but they also have the other stipulation is that x plus 8 is greater than 0, and that implies that x is greater than, and if I subtract 8 from both sides, negative 8. All right, is that okay? I had to let my dog outside. You can hear him barking. Sorry about that. Okay. That's Sandy's out there barking. So just ignore him. He's got to do his little spiel to protect the house. That's his job. Okay. So we have both these, and this is a conjunction. So I have this conjunction. X is less than or equal to negative 3, and x is greater than negative 8. And to get a good feel for that, I'll just use a number line and I'll sketch it here. This is x. And I've got negative 3 and negative 8, so here's negative 8 over here. Maybe negative 3 is over here, and maybe 0 is over here. Okay? And so now what we want to do is we want to put this over the number line. So x is less than or equal to negative 3. So I'll put a dot over here. And it's going to be to the left of negative 3. So I'll put a dot here. And there we go. And x is greater than negative 8. So I'll put a circle there. All right, this is what we've got. So double check this, please. Let's see here. X is less than or equal to negative 3, and x is greater than negative 8. So there's x is up. X is greater than negative 8, and x is less than or equal to negative 3. And where do I have both things happening at the same time? I could say it right over here, a circle. and a dot, because that's 2. So in there, so that's the part that satisfies that condition. Okay, and then we have case 2. All right, in case 2, we'll have a 10 over x plus 8 is greater than or equal to 2. And then we'll multiply both sides by, I'll rewrite this down because so when I multiply both sides by my x plus 8 in this case, since it's negative, I've got to circle my inequality because I'm going to change the direction, x plus 8. And now I have these x plus 8s become 1. So now I have 10 is less than or equal to 2x plus 16. Subtract 16 from both sides. And negative 6 is less than or equal to 2x. Divide by 2. And negative 3 is less than or equal to x, which implies that x is greater than or equal to negative 3. But this is also the case up here that we have that x plus 8 is less than 0, which implies that x is less than negative 8. And that's a conjunction again. So let's write that out. X is greater than or equal to negative 3, and x is less than negative 8. Let's do this on our number line. So we got negative 3 over here. This might be 0, this might be negative 3, this might be negative 8, and we have x is greater than or equal to negative 3, so we have a dot over here, and x is less than 8, and you can see that there's nothing here. There's no points where we have two lines because this is a conjunction. So this is just the empty set, or no solution. So we have, in this case, this conjunction. Now when we have it written like this, we can actually write it's between, so we can actually write this over here, that x is between. You can see that x is the values between 8 and negative 3, so we could actually write this, rather than writing both this, we could say that x is less than or equal to negative 3, and at the same time it's greater than negative 8, because it's between negative 8 and 3, negative 3 equal to negative 3 but not equal to 8, and we have or, because this is a disjunction. So we have either this solution or this solution. Well, this is no solution, so that's our whole solution. So actually negative 8 less than x less than or equal to negative 3. So that's our solution. X is between negative 8 and negative 3, can be equal to negative 3 but not equal to negative 8. So if it's this or this isn't going to enter to it because that's nothing, so it's that. Okay? So nice, interesting problems, both those. Pretty challenging. So see how you can do on those. Those are probably like what we would consider honors questions.